Alright guys, today we're going to talk about force in motion. Okay, this is part 2, or acceleration, and it's PS10A. So we're going to investigate and apply the concepts of speed, velocity, and acceleration when we describe motion. Alright, so the first part in your notes is engage your brain. So I want to take a look at these first three statements and decide if they're true or false. Okay, a car taking a turn at a constant speed is accelerating. Tell me if you think it's true or false. If a object has low acceleration, it isn't moving very fast. An accelerating car is always gaining speed. So list if they're true or false, and be ready to, at the end when you come back, to discuss them, and we'll compare our answers and discuss them in class. All right, so this is a quick daily demo. I want you guys to imagine a toy car accelerating. And when a car is pushed at a steady speed, do you think it's accelerating? Why or why not? These are all questions to think about as we go through the PowerPoint, and then we'll discuss them in class as well. Right? If I take that same car and I push it on a table and it's slowly gaining speed, is that accelerating? Explain what you think. And finally, what if the car starts out fast and slows down? Is that accelerating? So think about the different types of acceleration that we were just kind of discussing there, and we're going to do a quick demonstration when we come back together as a class. Okay. All right. Let's get on to the essential question. So at the top of your notes, write, how does motion change? That's our essential question. How does motion change speed? Okay. So we did a quick lab in class in acceleration and slope, and you needed to calculate the acceleration of a marble as it went down the ramp when the slope increased. So you and your members investigated and calculated velocity and acceleration of the marble at 3 different slopes. So we have a little bit of background with the acceleration. The first ramp, the marble didn't roll down as fast as the second ramp. So as you add books, your acceleration should increase. So let's get down to the main idea and some of the notes. So how do we measure changing velocity? Like we said earlier, it's acceleration. Okay? And acceleration is the rate at which velocity changes. Okay? So there are 3 ways you can tell something is accelerated. Whether its speed changes, it could change direction, like making a turn, going on 7, or going east or west, or maybe both of them can change at the same time. And acceleration depends on how much velocity changes and how much time it takes to change. So make sure you write these 3 down on your notes. So on this slide, we have a bicyclist. Okay, so someone riding a bicycle, and you're all pretty familiar with that. So what is the change in velocity for each second that time passes? Well, we look at the very first second, he's going 1 meter per second. And then at 2 seconds, now he's going 2 meters per second. And you can see the distance between is kind of growing there. 3 seconds, 3 meters per second. 4 seconds, 4 meters per second. And at 5 seconds, he's going 5 meters per second. So he's slowly increasing his speed. Okay? And that's what we mean by acceleration. So how do we calculate this? So average acceleration is calculated pretty simply. It says we take acceleration equals final velocity minus the starting velocity divided by time. So here's your formula. I want you guys to write down the formula as well as the notes. Okay? And acceleration is measured in meters per second squared. It's really important that you understand this. The speed is only meters per second, but acceleration is meters per second squared. All right, let's take a look at acceleration as a vector. Okay? So look at the horse. There's a horse at the bottom of the hill, and there's a horse at the top of the hill. So is the horse showing a negative acceleration or a positive acceleration? He starts off at the bottom at 13 meters per second, but ends up at 5 meters per second at the top of the hill. So is he positive acceleration? Is he gaining speed, or is he showing negative acceleration? Is he losing speed? If you take a look here, we started at 13, we ended at 5.5. This would be an example of negative acceleration. So just think about when you climb a hill. You generally, if you're running up a hill, you don't increase your speed up a hill. It usually decrease your speed. Okay. All right. How can changing acceleration of objects change velocity? So acceleration refers to both increases and decreases in speed. Okay. A change in direction is also acceleration. So if you make a turn, you go right, you go left, you go up, you go down. that is a change in acceleration change in velocity. So it's you can increase your velocity, which is positive acceleration. So if I go from slower velocity to a faster velocity, that's increasing speed, so it's a positive acceleration. Or you can go from a faster speed to a slower speed, and that is negative acceleration. So with this, think about your car. When you hit the gas pedal, you have positive acceleration. You're speeding up. Okay? When you hit the brake, you have negative acceleration. You're slowing down. All right, here's our first problem here. Okay, this is on the back of your paper. You want to take a look there. It says, a roller coaster car rapidly picks up speed as it rolls down the slope. As it starts down the slope, its speed is 4 meters per second, but 3 seconds later, at the bottom of the slope, its speed is 22 meters per second. What's the average acceleration? So take a moment here, and I want you guys to pause the video and work on this problem using our formula in our previous slide. All right, let's practice acceleration word problem number 1. So we talked about earlier that a roller coaster can rapidly pick up speed as it rolls down the slope. So in order to solve this, you need to first know the formula. An acceleration is A equals velocity final, that's what V lowercase f means, minus velocity initial, and that's what V lowercase I means, over time. So our initial velocity is when it starts going down the slope. And our 3 seconds later, at the bottom of the slope is the final velocity, 22 meters per second. So we take 22 meters per second minus 4 meters per second, because that's our initial velocity. And this happened over a period of 3 seconds. Okay. 22 minus 4 is 18 meters per second divided by 3 seconds. So, acceleration is 6 meters per second squared. And it's really important to put that squared there, because what you're saying is you're going 6 meters per second and you're squaring it each second. Okay? So, that's how you solve acceleration problem. Please do numbers 2 through 6 and be ready for tomorrow to review these questions as a warm-up. Thank you.